Hello everybody. We're going to continue our videos in section 1.1 and 1.2, and we're going to move on and talk about variables and data. Okay, so we're going to talk about what they are, how to identify them, different types of variables, and we're going to talk about how to interpret data. Okay, so what are variables? So when we collect data, we ask questions. Okay, we want to find out stuff. We want to know, how big something is, or how concentrated that pollutant is, or what breed of dog that is, right? These are the variables, the things that we're measuring, the characteristics that we're measuring. So the characteristics that we choose to measure, observe, or inquire about are called the variables. Okay? The data are the values that we measure from the variables. So if I do a study on eye color is my variable. The actual colors that I measure, those are the data. Okay? So let's just look at this example here. I got a sample of 6 people. The variables I choose to measure from those 6 people are gender, height, and weight. And the data are the actual measurements that I make. So for gender, we determine that they're either male or female. The height, we get various numbers for the height in centimeters. And for the weight, we get various kilograms for their weight. So the variables, each column will be a variable. Right? So if you look at the top of the column, they usually label it what variable it is. So we have gender, height, and weight. And then below the top row here is the data, the particular values of those variables. And each row is one individual. So this one individual was male, had a height of 150 centimeters, and weighed 80 kilograms. Right? The next individual was female, had a height of 163 centimeters, and a weight of 90 kilograms. Okay? So that's the difference between variables and data. What types of variables are there? Well, you can subdivide this pretty finely. We're just going to do this. We're going to break them down into numerical and categorical. And the numerical variables, we're going to talk about continuous versus discrete. You can break down categorical more, but we're not going to do that. And I think the book talks about this. I'm not going to go there. You're not going to be tested on this. A variable is numerical if its values are measured or counted using numbers, of course. Numerical, numbers. A variable is categorical if it's not numerical. So if you're not using numbers, it's categorical. Okay, so they describe categories or labels rather than counts or measurements. Okay? Now let's talk about these different types of numerical variables. Numerical variable is called continuous if there are no predefined gaps between the possible values, or if those gaps that do exist are just so small as to be negligible. And a numerical variable that is not continuous is called discrete. So there's a limit to how close the values can be together. So this is a subtle concept and one that students struggle with at first. So let me go through this in a little more detail. Let me first talk about just a continuous process. Okay. On a radio, you may have a radio with a knob for the volume. Okay. By adjusting that knob, I can adjust the volume to as fine a degree as I want. If I just want it a smidgen louder, I can just turn that knob just a little bit. If I want it a little bit quieter, I can just tweak that knob just a little bit in the other direction. There's no fixed settings for what the volume has to be. I can finely tune it to whatever volume I want in between any settings that you can imagine. That's what it means to be continuous. Continuous means there's just a continuous range of possibilities between any two values. On the other hand, there's discrete. So discrete might be the knob or buttons that determine what frequency you're listening to on the radio. So every radio station has some frequency like 93.4 or 103.2. The smallest degree that you can measure these frequencies to on a radio, that the radio allows you to do it, is 0.1. You can only go to the 10th place, right? You can't go to radio station 104.35. right? You have to jump from radio station 104.3 to radio station 104.4. There is a gap, right? The radio doesn't let you get in between there. So that is a discrete process. It has gaps between the values. Another way to quickly determine if it's discrete is if you're counting it. If it's something that's counted, if you're counting the number of siblings people have, the number of pets that they own, you're counting. Numbers that we count come in discrete steps, right? Counted things, you can't count 1.5 things. You just go right from 1 to 2. But just if it's discrete, it's not necessarily counted, but if it's counted, it certainly is discrete, okay? Variables would be variables that are measured with the same, regarding the same kind of, so that the values adhere to the same principles that I just described. So I could do a sample where I go out and measure the volume that people are listening to their radios at, right? That'll probably be a continuous thing, because as I just described, volumes can be tweaked to a minute degree. If I went out and took a sample of the radio stations they were listening to, and I measured the frequency, that would be a discrete random variable. If I measured the weights of people in kilograms, say, that I would call continuous, right? Because I can measure their weight down to as small a degree of accuracy as I want. Now you might say, well, wait a minute, maybe the scale only goes to 1/100th of a kilogram, and so really it is discrete because the readout, the digital readout on the scale only, is accurate to 1/100th. And so technically you're right, that would technically be discrete, but that change is so small compared to how wide a range of weights we see, it's essentially zero, right? It's essentially negligible. And so in that sense, we would call that continuous. Okay, so if the steps are there, but they're so tiny with respect to how wide the range of values are, then we would probably call the variable continuous. Okay. Discrete would be, like I said, things that are counted. If I measure shoe sizes only go up by halves, right? So there's a fixed smallest increment, so that makes it discrete. And then, like I said, categorical are things that aren't numerical, so like measuring eye color, breeds of dogs, things like this, things that aren't numbers. Now, it could be a number and be categorical. So let's see if we see an example like that. We're going to go through some examples here. See if you can spot the one thing here in this list that is a number, but is also categorical. So number one, species of trees. Okay. What type of variable would this be? Well, it's not numerical, so it must be categorical, right? Because a species of tree is like maple, pine, elm. Those aren't numbers. Has to be categorical. Number two, weights of dogs in kilograms. Well, I gave this example about weights. If I measure the kilograms to, really accurately, then it would be considered a continuous variable. Okay. Now, if I round to the nearest 10 kilograms, okay, discrete, because now I'm rounding. I can only go up by increments of 10, right? But I think we probably wouldn't do that if we were measuring dogs. That would be too rough a measurement. Number three, number of siblings of elementary school students. Well, this is numerical discrete, right? So weights of dogs is numerical. I don't know if I pointed that out. It's numerical continuous. Number of siblings is numerical discrete. Why? Because we count the number of siblings. 4, interest rates on loans. So you might have an interest rate of might be higher than that, 3.56%, 5.49%. They probably go to 2 decimal places. Since it's going to the 100th place, it's certainly numerical. I would probably call that continuous. Right? Letter grades of students in a class. Well, those ain't numbers, right? Those are letters, so those are categorical. Number 6, weighted averages of students in a class. So we're taking their numerical score on all their assignments and combining it into one weighted average for the end of the class. What would that be? Well, when you take these averages, you can get them down to a very small degree of accuracy. So it's certainly numerical, and I would call it continuous. All right, they don't go up by. There's no fixed increments there. They weighted averages. Two students' grades can be very close together without being the same. And then number 7, Social Security numbers of U.S. citizens. And I have a warning there. Be careful. Ask yourself, are these values measured or counted? And think about it. You don't measure somebody's Social Security number, and you don't count it. It happens to be a number, but it's really a label, right? It's a label that happens to be a number. So in this case, we actually wouldn't call this numerical. Okay? If we look at the definition of numerical, it's numerical if its values are measured or counted using numbers. Social Security numbers aren't measured or counted. They're just assigned, right, to people. So they're just labels. So these would actually be a categorical variable. So a little bit of a trick question there. All right, and interpreting data, the last topic. So when we see a data set, how do we interpret it? So this is just kind of a little bit of review of what we've already talked about. So the figure below displays just some rows of a data set for 50 randomly sampled loans offered through Lending Club, a peer-to-peer lending company. These observations will be referred to as the Loan 50 data set. Okay? Each row represents an individual loan. And there's a link here. If you go and get these slides online, you'll see you can click this link and go get the full data set. And you can load it up in a spreadsheet and go through and do some statistical analysis on it. And we will probably be doing that later in the class. All right, so let's answer these questions. What are the variables in this study? So remember, there's kind of 2 ways to get at the answer here, because I talked about how to identify variables in 2 ways. Conceptually, variables are the things that are measured. So what was measured in this study? Well, loans, you might say, but that's not really, yeah, those are the things that were sampled, but what did we measure from those loans? Well, we measured the loan amount. Each loan had a loan amount. Each loan had an interest rate. Each loan had a term, a grade, a state, total income, and whether it was for home ownership or not. This is the total income of the individual that took the loan. So these words up here, loan amount, interest rate, term, etc., these are the variables. And remember, I said that the variables are the things that identify the columns in the data set. So that's another way to get at them. These are the labels for the columns, so they must be the variables. It's possible to put your data set sideways, but usually people don't do that. But be aware that could happen. What types of variables are they? So we have numerical or categorical, and if they're numerical, are they discrete or continuous? Well, let's look at loan amount. Okay, loan amounts have a lot of different numbers here. Well, I don't think that, so these all have a smallest, I mean, it looks like nothing gets finer increment than 100 here, but I would bet you that if you go down further in this list, you could have loans that maybe were a little bit more specific. There's no reason why a loan couldn't be offset by just $1. And $1 in comparison to how large these numbers is really small. So you might say that because they're all rounded to the nearest dollar, they're discrete. But I think most people would say that that $1 is so small compared to these numbers that they're essentially continuous. Okay? What about, so this is numerical continuous. What about interest rates? Again, numerical continuous, because the increments that these can differ by are so small compared to how large the numbers are. They differ by hundredths, right? Now the terms here, the terms look like they're certainly numerical. It looks like they probably go up in, these are probably in months, right? Now, here it's iffy. Without being able to see the full data set, it's hard to say for sure. If you could have a 4 or 5 month loan, if loans could differ by just 1, then it's borderline. You might call this continuous, you might call it discrete. If they're going up by 12s, which might be happening. So they're only going up by lengths of a year at a time. If they're going, the increment is 12, that's a pretty big increment, and then I would call this discrete, because this 12 is a pretty big chunk compared to the size of these numbers. So looking at these, I might say numerical discrete, but I'd have to see the full set to be sure. The grades. Well, it's not a number, so it's categorical. States, not a number, categorical. Total income. Well, here I would put in the same category as loan amount. I would say this is probably, I would label this numerical continuous, because incomes can be quite varied and can differ by very small amounts. And home ownership, whether the homeowner that was taking the loan was renting or mortgaging. Well, there's only two types, rent or mortgage. They're not numbers, so that's categorical. Okay? So I think that's it. Yep. So that's it for this video. I will see you in the next one.